Alright, so let's have a look at how you can edit inside a system. So mainly let's talk about system requirements editing and maybe also about some user stories and how this all works. To do that, I will go into my example system and I will prepare a new system version. So let's just assume I want to work on the next version of our system, and I decide that the example system and that admin app should be changed. So in this process step, I actually prepare the new structure for my system of systems, and I have decided that there will not be any updates on the operating system. Maybe the team here working on the operating system has a complete different release cycle. So I cannot wait for them. I will stay on version 1.0, but I need to update the admin app. There are these naming conventions here. You can change here in the version handling. So if you prefer your own namings, just use replace. Or if you want to keep them, and you can prefix them, but if you want to keep the standard one, keep the new version empty field, the new version field empty, and then just go as you are. Alright, so when I hit complete, what happens is two new system work items are created, and all the documents inside, they are branched. So, and we see only these two systems because the third, the operating system, was not there was no need for creating a new version because we wanted to keep the old one. Now, if I open example 1.1, we can see in the structure that this is now different. We have example system 1.1, admin app 1.1, but operating system 1.0. So this already is quite helpful because, for example, if you're working on operating system, you can see in this section here that the version 1.0 is actually used in two systems, in two system versions, in example system 1.0 and 1.1. And you can imagine the operating system might be reused in many other systems. You would all see them here, and you would have a better understanding what it means when you do some bug fixes and which systems should ensure that they get the patch and so on. Now, let's go back to our example system 1.1, sorry, and let's create some things we can work on. So to implement something, we need changes, defects, and user stories. So I will just create a little user story here saying that the red feature should allow only integer numbers. Very simple. And now, again, you see a standard Polarion user story, which I would need to push through the process until I can plan it. I will shorten this a bit. So I quickly accept it, add some story points, and say, okay, this is at least now estimated, it's assigned, it's good, so we can implement it. And that's the precondition actually to start the implementation. So the user story is our, I sometimes call it a delta requirement, because this is the description of the change, but not the description of the result. So now that we have created the user story, it would make sense also to plan it. And to do that, I'll create a plan for that system version 1.1. I just take the settings as they are, hit create, and you can see it was created. I click on example system 1.1. It's basically the same as a standard Polarion plan with some little additions like showing me to which system that plan belongs to and also which release is related to that system. And now I could say let's add work items to the plan. And this list here is a pre-filtered list showing me all objects from all work items from example system 1.0 and 1.1. So it builds already the correct backlog for me and hides all the other work items which might also be there in the system. Here is our red feature, so I will add it to the plan, and I could for sure also add other objects as well. So let's just add these two, save it, and if I go back to my plan, they are now here ready to be processed. So let's say this guy goes into progress, and I will have probably maybe some subtasks, but don't go into this now. I guess if you know Polarion, you know all the flexibilities that you have in creating subtasks and doing all the planning. Right, so plan is ready. Now people work on the implementation and others need to update the specification. So how do I update now my specification for 1.1? I'll go into the document and, well, I have to work now on my specification, and here is the requirement I want to change, and I can only change it with overwrite because it's a reference. It's an object which is shared across different documents. So to change it, I will choose this override function. And now I say the red feature can be configured in the admin app using only integer numbers. And maybe another requirement is also affected, maybe this one, so I will also override that one. I'll just say integer here for us. Integer. That we easier spot it later on. So now when I save it, the template knows that there are actually linked work items which have also been branched and referenced, which should be updated. So when I click on this feature, you can see here on the right side, there is a requirement which became suspect. When I click on it, I will end up in the correct document showing me that that requirement on the admin app, and I can say here I also do my change, so only integer. And when I click on edit links, I can remove all the suspects related to this requirement and hit the confirm button. As you can also see, this requirement again has a sub requirement, is refined, and so on. So the change is propagated via the suspects along the chain. But this is standard Polarion again. So what's the difference here in this template? The difference is that we work with references and not on the latest version. And so whenever something is changed, linked work items are also overwritten. And that's it basically. And that's how we continue to work. Well, I forgot one thing. Currently, the process does not enforce you to select why you changed the requirement. But I think it's good practice to say always why you changed something. So you can use this field. That's the reason why this field is there. Changed because you can pick the user story which was the root cause of that change here. And if you link it, then later on it's easier to find out what is related to that change request. Actually, I should also do that in the requirement that we've changed. I forgot that, so let's do that now. Also pick here the red feature with the integer change request. So that was my change. What do we see now? If we open, for example, the system, the user story, you can see that the user story now gives me a complete list of changes that were done in the specification. And as you know, Polarion can also link source code changes to a user story. You have now the complete package. We see the requirements which have been changed. There is also here a diff that you can choose. And if you've linked the source code, you can see also the linked source code. We can see that there are 2 new requirements, 1 new test case. And to better understand if we have completely updated all the specifications, you have these 2 options here, the suspect work items on a system level. So clicking on this will show me all suspects in this specific system version. And actually we have not yet updated the test case, which is linked to this requirement that was changed. So when I click on the requirement on the test case, we can also see the requirement description. That's a little add-on provided by the template, so I can read here. and maybe I spot it directly. Otherwise, I would need to open the item, look at the history to understand what was changed. But we know that, and so I would also need to change here the integer information and then again remove the suspect, which I can do here. The same is also available on a system of systems level, because this system is using or is having other subsystems it's connected with. And so is there maybe any impact here? So if I choose SOS suspects, I can see there is a lot more of objects on the admin level I would need to change, all related to the red feature. And now I would need to process these objects to see if they are consistent. But without these suspects, we just run or we just accept the risk that we work on inconsistent information. And that's what we don't want. So that's why I think these suspects are really helpful, because the changes are there. You have to double check if the description are still correct. All right, so what we did up to now was creating the user story, updating the requirements, resolving the suspects, and we also planned a bit, very, very little. How can we understand how things are connected? So there are different reports that you can choose, either on a document level. Here you can see there is a requirements coverage report. So when I open this one, it will show me a document-like view, but additionally to the requirements of the document, I see on the right side the objects from other specifications inside the same context which are linked. And if we scroll down, we can see also here with a blue bar, these are the new requirements that were introduced. And you can see the integer numbers on this level. And we can see here the red feature, which got now the integer number feature. And you see here also this one is correct. So we can easily cross-check just by reading both requirements in parallel. Okay, right, this looks good and it's consistent. And so we have now the option to work in these two streams, so to say. So this is example system 1.1. If we go back to example system 1.0, so you see here you can just navigate up and down the different versions. Now I'm in 1.0, and if I open the trace from here, showing me the requirements coverage, you see the red feature without the integer. So the system is aware that you have the two different contexts, and that's what the SOS template brings you, this context of showing you which objects belong to which work items, which documents belong to what system, and then builds the correct traceability. And that's all for now.